Today we're going to look at how you can detect projectile collisions, but we're not going to use a physical bullet. We're going to use a RAYCAST physics simulation that Godot provides out of the box. Now this is going to be a multiplayer setup, but we're only going to be looking at how to detect these collisions on our enemy mobs. We'll get to the PvP stuff in a later video. To get started, we need to set up a couple inputs, but before that, I just wanted to mention that this tutorial builds off the basic multiplayer 3D project that I've developed, so go ahead and pick that up and follow along with the previous sets of videos so that you're all caught up. Okay, so the first thing we need to do is let's detect a left mouse click. So go under project settings. We need to create a new input for the left mouse button. So let's go ahead and hit add new action. And once you have that created, go ahead and hit the plus sign and then just click left mouse and hit OK. And then go ahead and close that. And now we just needed to get that out of the way. So the next thing we need to do is take a look at our player's input synchronizer script. Okay, we don't need to see our replication. Nothing's going to change there. And let's just scroll down to the place where I'm processing the input. So right here. So let's listen for that left mouse click. And let's get a reference to our camera. So what we're doing here is we're establishing our origin and the projection of the ray from our camera, which sits behind the player, to the center of the screen. So if you remember or recall, in most first-person games, you're gonna have a fixed crosshairs dead center of the screen, and it's always going to remain there. So we're going to leverage the location of that and the location of the camera to create a projection ray that will shoot out into the 3D space of our game. So in order to do that, you use the camera and you project a ray origin, or you establish a ray origin using the event position of the mouse. So there's some magic going on here, because if you look up just a little bit above this, let me see if I can find it. This logic right here says that once you're playing on a client, you're going to capture the mouse mode into the center of the screen. So if you go and look at that, it captures the mouse and it will be hidden, but it's locked at the very center of the screen of the game. So what we're going to do is we're going to leverage that so that we know where our origin is going to be. So you're basically taking a ray and you're establishing an origin from the camera to the event position. And that's going to be where our ray starts. Now, if we have a look at the docs, and this is the ray casting docs that Godot provides, they've got some pretty good examples here. You can see here that the ray origin, regardless of your camera type, is going to be established at that, behind your eye at the camera. And then what we're going to do is project a ray normal, and we're going to use another calculation you can see down here in this little snippet here to project that ray out into 3D space. So if we come back here, we're going to use that projection ray origin tool here from the camera to the event position, which again is that mouse centered at the middle of the screen on the crosshairs. And then we're going to also create a projection normal ray from the camera to that event position. So you're basically establishing that origin in space, and then you're also creating a normal of a vector that points in the direction of where that ray cast should go. And because this is the fire button, right? So this is if you have a gun and you hit the left mouse button, you're gonna go ahead and fire that weapon. We actually need to make a call to shoot that gun. But before we do that, we need to create a new object under our player scene. So let's create a new 3D node. And I'm just gonna name it GUNFIRE RAYCAST. You can name it whatever you want. And let's go ahead and create a new script here. Put it in the right location. Okay, so this script is going to act as the mechanism where we can fire our weapon. Now, you can probably set this up a few different ways, but just to get started, I thought this was a pretty straightforward and easy way to get going. Now, this script will be attached to that player object, and it's going to act as the script that handles gunfires. So because this is a server authoritative setup, we're going to see some RPCs here, and we'll get to that in just a second. So the first thing we want to do is establish some variables for our script. Okay, so we've got our ray length, which will be the length of the ray that we cast, so that maybe you don't want it to shoot all the way across the map, but you only want it to go 1,000 meters or whatever the ray length will map out to be. So you can adjust that here based on your game's requirements. Our collision layer ID, I'm gonna circle back around to this in just a second, and whether or not we need to check for a gunfire, and of course our camera mouse ray project. And that again was, we created that over here in this side. So we're gonna pass that over to the gun RAYCAST script. Okay, so for the ready function client side, we're not gonna run the process or physics process functions for now. We may add that back in if we're gonna add some animations to this, but for now we're just gonna turn it off. Okay, let's add in our physics process function. So what we did here is we're gonna detect if we need to actually check for a collision. Now, you may be wondering why I did it this way. Well, if you look at the docs, you can see down here this little blurb where they say that basically in practice, you should be running these checks in the physics process and not off a branch of the input because it could be locked. Now, I'm not 100% sure if that would be blocked if we just did this on an RPC call. I'm gonna lean towards no, but just to be safe, I'm gonna definitely run this out of the physics process. Okay, so next we need to create a check hit function. And then we also need to build out our RPCs. Okay, so we're gonna use this fire shot RPC to make a call from our player input script. So let's go ahead and just wire that up now that we have it. So we can drag this over. So then we're gonna pass in the origin and the camera mouse ray projection. So on the client side, this is going to establish the origin and the ray normal based on our mouse and where the crosshairs are on the screen. And we're going to pass those variables to the GUNFIRE RPC to actually kick off the shot, but it's going to be called to the server side. So this gunshot and those calculations of whether or not it's detected an object are going to be on the server side. Okay, so I printed out a fire shot just for debugging, and we set our origin and our camera mouse ray projection here to these variables. And then we'll go ahead and set the check hit to true so that our physics process will go ahead and execute that check hit call. So let's go ahead and finish out that collision detection. Okay, so what we're doing here is we're calculating the end of our RAYCAST using the mouse ray projection times the length of the array. And again, you can adjust this to suit your game's needs. And then we add that to the origin. So that's gonna give us the endpoint of this RAYCAST. So down here, we take this physics ray query parameter, we create that parameter using the origin and then the endpoint of this RAYCAST, and then we give it a collision layer ID that we only want it to detect with. Now, you can adjust this or you can completely leave off this part of it depending on your game's requirements, but this collision layer is going to allow you to say only query the RAYCAST on specific layers in the game. And we'll get to that in just a second. And then this last parameter is things that you want to exclude from your RAYCAST. So in this case, I'm excluding the player mesh themselves. So we don't have ray detection showing up when they're firing it and they accidentally, like in a third person view, and if you look down on your player and you accidentally fire, it's not going to detect hitting yourself. So you're basically eliminating any possible collisions with yourself. So we take our query and run it inside the intersect ray function, and then we get our result. So the result is basically going to tell us what we collided with. Now, if we do a quick peek back at the documentation, the actual result will be something like this. You'll have the position or the point in world space of the collision, another normal that results from the world space of the collision, the object that you collided with, and of course the collider ID. Now, the way I'm going to detect it is I'm going to use this collision layer. So all my mobs are going to be on a specific collision layer. So let's jump really quick over to my mob and let's click on him. And down here under this layer, I'm going to use layer 13. So go ahead and hit under collision, drop this collision drop down, open this collision tab and hit that 13 there and just go ahead and hit save. Now, if we come back into this script, that collision layer ID, we calculate by using this little formula. Now, I got this formula using this example under the Godot doc. So if we scroll down and look at this example, you'll notice right here, they give you a little formula for how to calculate the actual bit mask for that layer. So you use their math function, power to 2, and then whatever your layer is -1. So that's exactly what I did here. And that's how we get our collision layer. So just to recap, if you go look at the mob, he is on collision layer 13. And so we're gonna make sure that this query only collides with that layer 13. Now, again, you can adjust this for whatever you want for your game, but for this demonstration, I just wanted to illustrate how easy it was to exclude or include certain things. Okay, so what I've done here is I created a conditional that says, do we have a result? Is there a collider in that result? And is that collider a mob? And then if it is a mob, we just go ahead and print out hit so that we know in our debug console, and then we go ahead and call the kill function on the object that we just collided with. Now, I did this check here is mob, even though it's not necessary in this example, because remember, we have everything locked down to layer 13, but because I wanted to call a kill command, I wanted to make sure that it was a mob if some other object got onto that layer by accident. Now, it's probably a little bit overkill, but you can adjust it for your game as needed. So that's pretty much all that's required to simulate a projectile collision detection. So the next thing we need to do is go ahead and finish up this demo by building out the kill function under the mob. So let's go back over to our mob script and let's go ahead and create our kill function. And we want to make sure that we're only on the server doing this. Okay, here we've set our current animation to animation die so that our mob will die and show that animation. And we set the target player to null just to make sure there's no extraneous calculations being ran where he's trying to chase somebody, even though I have it all excluded, but we'll get to that in a second. And then this mob kill RPC is an RPC that we call from the server side back to the client side to finish up any client side cleanup that we need to do on that mob. And then of course we set the mob to dead. So let's go ahead and make that mob kill RPC call. Okay, so we got our mob RPC, and let's go ahead and create our dead variable at the top here. And we need to add this kill mob animated function so that we can just show that final death animation. Okay, so just to recap, back in our Gunfire script, when there is a collision detection with a mob, because it's collided with that layer that was specific to the mob, that 13 layer, and that we detected that it was an actual mob, and we know we're safe to call this kill function on the collider because we know it's a mob. So back over in the mob, it calls to this function here. So this isn't actually an RPC, but this is going to be on the server. So we make sure it's on the server. We set the current animation to die so that mob can fall over and die. Our target player is null so that we stop any extraneous calculations. And then we make a call to a local RPC, which we've defined here, which means only a server can call with this authority. And in the case where you're running in host mode setup, we have to enable this call local parameter as well. And then of course we mark the mob dead and then kick off the death animation on the client side. And down here, I have a slight refactor of this animate method. It's a little bit of an improvement, so let me just build that out really quick. All right, so this is much more succinct, as you can see, because I'm basically just marking these true or false based on what the current animation is. So of course, if the current animation is idle, this will be true and the other two will be false so that we won't have multiple animations competing for each other. I'm still thinking there might be a better setup to this, but this is where I've gotten with the animation tree setup so far. And of course, if the player is dead, do not run these animations. And that, of course, is why I created a separate method to handle the death animation for the mob. Okay, now let's add in this dead check in a couple more places in this script. So this is going to be when a player loads on the client side. If it detects that a mob is dead, go ahead and kick off that kill animation. This is a bit of a hack, and I'm going to have to figure out a better way to do this. But for now, what this would happen is if like you had two players running around, or if you had one player running around and that player killed a mob and then the second player spawned, well, the mob would just kind of be standing there because the death animation didn't happen. So just for now, if a second player drops in with a mob that's already dead, all those mobs will just go ahead and fall over. I know it's a bit of a hack, but it just makes it look a little bit better than a dead mob just standing there. So this just makes sure he's on the ground by the time that character loads in. So that's, again, it's a bit of a hack, and I'll revisit that a little later. And if we go down to the process function, I don't want to run any process if the player is dead. And the same thing under the physics process. Okay, and then the last thing we need to do is let's go over to our animation tree and let's set up our death animation. Okay, so if we look at our animation tree, and I'm assuming you're gonna have a death animation already, and I'll go ahead and let's create a new animation here. We'll do dying as the one that I've got, and then we'll make a connection from I guess any idle, whoops, let's just go the other way. So I'm gonna make a connection to dying from each of the animation states, because at any point, whether he's just standing there, running or walking, he can actually die and fall over. So that's what you see there. So if he's walking and then he hits die, yeah, he'll go ahead and die. So let's go ahead and also make sure that we set up our transitions correctly. So we select this and then come over here and hit die. Die. And then one more time. Great. Okay, so we can close that and we can go back into our script, just kind of land there. And just to recap really quick on that die animation, if we look at the kill mob animated function, you can see here I have that condition die, which is what we just set underneath these connection things right there. So that is basically connected to this right here. So when we set that to true, he'll go ahead and fall over. Okay, so for the last thing I want to do is let's create some crosshairs that show up in the middle of the player screen. So let's go ahead and create a control, and we'll just call it crosshair container. And then let's go ahead and create a child that is a texture rectangle. So this is gonna hold the crosshairs in the middle of our player's view. So if we switch over to 2D view, right now it's up here. What I found that works is if you come down to this transform and you do the full rectangle on this, and again, these bounds are gonna match the size of your viewport. So if your game has support for multiple viewports, you may have to adjust this with your code, but because I'm locking the viewport size right now, I'm not gonna worry about it. And then come down here in the texture rectangle under layout. And I think what we'll do here is under layout mode, we'll set anchors and then we'll just set center. And that should bring that rectangle right to the center there. Okay, so right now this is gonna work, right? Because you don't actually need crosshairs. Your mouse is what actually triggers the gunshot origin of that raycast. But to give it a little bit of, visual side of things, let's go ahead and add a crosshairs image. So let's go under assets, and I'll just select textures and I'll just add a texture over there. And then we'll drag that texture up into our texture rectangle, and there it is. It's very basic, no frills. So, if you wanna build this out a little nicer, go ahead and find a really nice crosshair image or spend some time on it, and I'm sure it'll look great. Okay, so let's just go ahead and run it and see where we're at. All right, so you can kind of see in the middle of the screen there that there's a big crosshairs that's gonna be floating above him. Now, this is a third-person game, so there's kind of some gotchas with it, but in a first-person view, this would be perfect, and you can basically just run around and change this to a first-person mode game, and it would work exactly as expected. So right now, if we hover over a player or an enemy mob and we hit left-click, oh, it gives us an exception. So what did we do? What did we miss? Okay, so it's multiplayer server is not a thing. So let's correct our typos and rerun it. Okay, let's try this again. So if we locate let me turn off the fog. It's a little hard to see right now since we're just testing. Let me go over to the map, environment, and we'll just turn off that fog just for now. There we go, we can see a little bit better, right? Okay, so if I run over and I find a mob and I hover over him and I click it, okay, you can see there that down in the console it said fire shot, and check hit. So we went ahead and checked hit. Oh, I caught him that time, and look at that, he died. So looks like we've got things working. Let me see if I can shoot some other mobs. Got one there, got one there. Here's one, got him. And now I can shoot in space, like you have to actually hit him, and there we go. So I'm basically wiping out this whole population of mobs walking around this town, and it's working as expected. Now you'll notice that I can turn and still shoot with him facing the wrong direction. That's gonna be for another time. That's a little bit more work to get him to spin the correct location. But the controls I have set up for this game, I'm not actually happy with, because you can run forward and then press, S, and then he faces you and run towards you. I don't like that functionality. I'd rather him just run backwards. So for the requirements for this setup, I need to work on some of the logic to fix that gameplay. But overall, this is working as expected. So before we move on, I wanted to mention something earlier about our input process. So there might be some examples floating around that don't use event position. This event position is from the Godot documentation, and I wasn't using it to begin with. I was actually using get viewport mouse position, but for some reason that wasn't showing accurate results. So from my experimentation, using the event.positions location of the mouse is the most accurate. So I would use that when you're doing your calculations. And the other thing to think about is there may be some issues with client-side cheating and that sort of thing because we're calculating the origin and the mouse ray projection on the actual client side and passing that. So to cut down on that a little bit, I still do our final calculation where you apply the length of the RAYCAST on the authoritative side, so on the server. But I think if you guys can think of a way how this could be, you know, manipulated or an exploit or something, let me know. But I didn't really want to dig into that for this demo. But just be aware that there may be an instance of cheating that may occur within this by calculating these two things on the client side. And another thing I wanted to show you guys is let's go ahead and see how we can debug these RAYCASTs. I thought this was a really neat tool and seeing why there was an issue, right? Because I said when I was using the get viewport method, it was a little off. And then when you shoot the RAYCAST, you can't really tell like why is it off. But I found a way to actually debug those RAYCASTs. So let's take a look at how to do that. So if you come back over to this GUNFIRE Ray script, and over here, let's just create another node and we'll call it debug. Oh, I always do that. And then we'll do node 3D, name it debug. And then in there, let's just create a RAYCAST 3D. RAYCAST, okay, cool. So after that result collider, regardless if it detected a collision or not, let's just go ahead and see where that ray shoots out at. And one more thing I want to do before we finish up on this side is if you look at, leave the thickness to 2. I thought that worked really well. And I'm going to change this to blue so we can see a blue ray. So what'll happen is when it detects a collision, it'll go red, but when it doesn't detect a collision, it'll just shoot a blue ray. Okay, so what we're going to do is we're going to take that RAYCAST and we're going to set its origin, so the beginning of it, to the origin of the actual RAYCAST that we calculated. And then we're going to set the target position, so where it's going to shoot to that ray projection given the ray length. But before this RAYCAST is going to work, we need to go over to the debug menu and hit visible collision shapes. Otherwise, it will not show up. So, you know, don't lose too much time on that. Make sure to go set that debug thing there. And I think you can see it's just our RAYCAST is just floating up there because, you know, this is for debug purposes or whatever. But now that you see everybody's collision shapes, you'll also be able to see the RAYCAST. So we'll just go ahead and shoot that and you can see exactly where it hit him right through the middle. This is actually really cool. And then we'll go ahead and snipe this guy. Boom. Oh, I missed him. There we go. Laser right through the heart. I love this. I love this. This is like the most fun debugging I've ever had. All right, there's a guy over there. Get him. Oh, I missed him. There, got him. Right there. No. There we go. No, I keep missing him. Man, I am not good at this. There we go. Oh, I see what's happening. So if you look at these guys, their collision is actually a little further back from where actually their arms and head are. So their head is actually outside of the collision container. I don't know if you can see that right there on this guy, but the collision capsule, that little capsule that he's walking amongst is actually behind his head. So to get a headshot in this case, I'd have to hit just slightly behind him. And I still didn't get it. Let's see, right, got him. All right, so there's one over there. But yeah, so, you know, you can adjust your collision shape to be a little larger or to, you know, encapsulate that body shape a little bit better, or just get a better animation or a better mob. I do plan on switching these mobs out eventually. Let's go ahead and shoot them again. Great. So if I don't hit anything, it shows up blue, right? So if I hit this tower, it will actually show up like I hit something, but it doesn't really matter because we're not detecting those collisions. So actually let's drop in another player. Actually, I do want to show you one more thing before we move on, just to kind of prove that this is working. So right now we have this collision layer mask or layer set to exclude anything other than what's on this layer. And I showed you how to calculate that earlier. So let's just do this. If result in collider, let's do this. In collider, so this is just saying if we hit anything, we'll go ahead and say, let's print out hit something. Okay, so in theory, this should not show up unless we hit a mob. It shouldn't show up if we hit a building or the ground or anything else because we have this filter on here. Hopefully I did this correctly. So if we hit this, look at that. If you look at the console log there, you'll see that it doesn't say hit something. So I can shoot the ground, I can shoot me, nothing happens. It's not gonna say hit. But if I shoot a zombie, boom, missed him.
Oh my God.
It hit something. You could see down there in the console log, it shows hit something and hit, and we killed him. So that means that this filter here is working as expected. And again, like I told you before, to get that filter, you look at your mob and you go down to his collision layer, and I've got him on 13. And if we look back under, I've got 13 minus 1 to the power of 2, and that's basically how you calculate that. And I explained that earlier in the video. So that's a cool little tidbit there. Let's go ahead and run this with multiple players. Go under debug, and let's just run 2 instances just to verify everything's working as expected. And you won't see the RAYCAST in this in the multiplayer because I'm in the multiplayer setup because I'm not syncing it. So, okay, so there's the other player. You can see that I'm jumping around. Oh, and by the way, if you guys do pick up my new project, I did adjust the jump logic. I was getting some feedback on it, and I did have some people asking me to update it. So I made it a little bit more structured, and I think it's a step in the right direction. So I did some refactoring. So if you end up picking up the latest project, you'll get that as part of it. So let's just make sure that everything's working. Okay, so you can see both of us are simulated. So now if I shoot a mob, that guy in the sun there, I'm not hitting him. Yeah, okay, I missed him. Okay, now you can see him die on both screens. So let's just move up a little closer. Yep, and you can see on both screens that mob passed out, dead. Let's do another closer one just to be sure. Let me find a guy. Here's a guy. And you can see him walking off the edge of the screen there, and we'll go ahead and shoot him, and immediately that death is synced between the clients. So the beginning of the RAYCAST is calculated on the client, and then we pass those to the server to actually do the detection. So it's the server side that's actually taking those parameters sent from the client and performing the collision calculation. So that collision is 100% calculated on the server side here. So it calculates whether or not that RAYCAST hit or that gunfire hit another mob, and it will go ahead and update that mob as dead, and that is immediately synced because we're synchronizing that dead parameter. If you go look at our project here under replication, under the mob synchronizer, you can see here that we are not actually calculating if he's dead. So let's go ahead and add that. That's a good catch there. Let's go ahead and add that. We'll go ahead and always synchronize that. And that is not under gunray, that is under the mob. So we'll go ahead and calculate the death just so we're sure that he's dead. And the reason why that actually worked, now that I was thinking about it, is because we actually synchronized the current animation. So in theory, you would see the mob pass out and die, but he wasn't actually considered dead because it wasn't synchronized to all the clients. So our clients didn't actually know he was dead. So let's just go ahead and rerun and make sure everything is working as expected. Oh, nice. I was gonna snipe him from up there. Oh, well. Okay, maybe our client will land up there. Nope, okay. All right, so our client runs around, and we'll go ahead and shoot a guy or shoot a mob, and we'll go ahead and die. Yep, everything is working as expected. He's dead. And let's try it from our server side. Let's try to shoot one of these guys near the market. Got him. All right, so this is a lot of fun. You can see exactly where that ray is going. So just to show you a little bit, like if I want to shoot this pot and shoot the pot, it goes right through the middle there as expected. So this is working great. Now, if I hit the other player, it doesn't detect anything because we're not detecting other players. Let's do PvP in another video. So if you want to see that, make sure to comment below and let me know and give this video some likes if you guys are interested in this track. I plan on doing a few more videos about this stuff because I think this is kind of like an introduction. We haven't done any PvP, and we don't have a gun in our hand, right? We don't have any animations for that. And I do have that in the works. So let me know in the comments below if you want to see that. so that I know to make these videos. And just so you guys know, like most of these videos I'm doing are suggestions from you guys. So please, if there's something you want to see, let me know and I'd be happy to take a look at it. So this is like the 4th or 5th video in this series that we have right now, building upon the same base project. So if you're following along, you'll know that these mobs are wandering around through the navigation region and navigation agent. So if you want to learn more, go check out the last video. But I think for basic gunfire techniques, this works pretty well. Maybe there's some issue if you want to spray a bunch of bullets. I'm not sure you'll want to be spamming RAYCAST. You'll probably send like a RAYCAST every few milliseconds to see if you hit somebody else. I think maybe that is a better way to do that. There's also a like RAYCAST that spreads out like a giant fan, so you can detect anything in the plane. So you can do some shapes and some things with that. That might be a cool addition to this. So anyways, let me know in the comments if you've enjoyed this and if you want to see me expand upon this example some more and see where that goes. All right, well anyways, I think that's it for today. Thanks for watching.